We want to evaluate the indefinite integral. We just found this antiderivative using trig substitution, and now we'll show how we can use basic u-substitution to find the same antiderivative. Normally when performing basic u-substitution, we let u equal the higher degree part of the integrand, hoping that differential u fits the remaining part of the integrand. But in this case, we're going to let u equal the radicand of 1 plus 36x squared. So if we let u equal 1 plus 36x squared, notice that differential u would be equal to 72x dx. So if we divide both sides by 72, we could say that 1 divided by 72 differential u equals x dx. So looking at the integrand, notice how we don't have x dx, we have x cubed dx. So this x would take care of one of these factors of x, but we have a factor of x squared remaining. What we can do here is solve this equation here for x squared. That would give us a substitution in terms of u. So if we solve this for x squared, we'd begin by subtracting 1 on both sides. Notice how that would give us 36x squared equals u minus 1. And now if we divide both sides by 36, we can say that x squared equals the quantity u minus 1 divided by 36. So now we'll perform substitution using u equals 1 plus 36x squared, 1 over 72 du equals x dx, and x squared equals the quantity u minus 1 divided by 36. Before we do this, though, let's rewrite this as the integral of x times x squared. Let's write the square root as the quantity 1 plus 36x squared to the 1/2. So now, again, x dx is equal to 1 over 72 du. Let's factor out the 1 over 72. We have the integral, and then we have du. And then x squared, again, is equal to the quantity u minus 1 divided by 36. Let's factor out the 1/36th, so we can have 1/36 times the quantity u minus 1. And then we have the quantity 1 plus 36x squared, which is equal to u raised to the 1/2 power. Now let's go ahead and distribute. 72 times 36 equals 2,592. So we have 1 over 2,592 times the integral of, this is u to the first, so we'll have u to the 3/2 minus u to the 1/2. And now we'll find the antiderivative with respect to u. So we have 1 over 2,592 times the antiderivative of u to the 3/2 would be u to the 5/2 divided by 5/2. Instead of dividing by 5/2, let's multiply by 2/5. So we'd have 2/5 u to the 5/2, and then we'd have minus the antiderivative of u to the 1/2 would be u to the 3/2 divided by 3/2, or 2/3 times u to the 3/2, and of course plus c. And after the last step, we'll substitute 1 plus 36x squared for u to find our antiderivative with respect to x. Let's go ahead and do this on the next slide. When we distribute here, notice how a factor of 2 will simplify out. So our fractional coefficient is going to be 1 over 6,480. And then we have u to the 5/2, which would be 1 plus 36x squared to the 5/2. And now for the second product here, a factor of 2 does simplify out. So we're left with minus 1 over 3,888. And then we have u to the 3/2, which would be the quantity 1 plus 36x squared to the 3/2, and then of course plus c. So this would be our antiderivative. So if we compare this method to the trigonometric substitution method, as long as we recognize the substitutions using u-substitution, is shorter. I hope you found this helpful.